Hi guys, welcome back. This is part of my networking series. Last time, or the last networking video, we created a bare bones server. This time we create a bare bones client to connect to the server. And we always start coding after the fade. Okay, so we're going to go ahead and create a new C++ project. So this is Visual C++, empty project, and I'm just going to call this bare bones client 2017 for the name of the project, and that's going to give me a completely blank slate. So I'm going to create a new item in here, and I'm just going to call it main.cpp. And now I'm going to add the include files in my pragma comment. And you'll see this is very similar to the bare bones server. And if you haven't been following along with this tutorial series, then have a look. There should be a card up there that links to the bare bones server, and also the sort of introduction to network sockets as well. And that kind of gives you a sort of basic idea of how sockets work. Okay, so I need to include a couple of things because we need to have some libraries to do things with. So I want to include IOStream because I want to use CIN and COUT. I also want to include the WinSock TCP functions, and then I want to tell the compiler to also link this with the WinSock library, and the way we use that is we use a pragma comment. So do pragma comment lib, and then we specify the library we want. So in this case I want the 32-bit lib file because it's a 32-bit program we're building. And then I'm just going to add this up here. You can decide not to do this and make this. There's lots of reasons, and the internet's full of them as to why this is a bad idea. It is a bad idea. It's bad programming practice, but for the benefits of this bare bones client, it's good enough for our purposes. Then we have our main entry point. Oh, and I also want to include strings as well. For no other reason other than just to show you that we can use strings, but we can use C++ style strings with networking. We just need to do a couple of extra kind of conversions across. So without further ado, the server I want to connect to is the bare bones server that we created in the first part. Again, link is up there somewhere. So I want to say that the server's IP address is going to be 127.0.0.1 because we're connecting to the local machine, and the port number is 54,000, which is also the port number for the server. So this is our listening server. So this is the IP address of the server, and this is the listing port number on the server. So our application is listening on port 54,000. So the server application is listening on port 54,000. So what we want to do here is we want to initialize WinSock, create a socket, fill in hint structure, and I'll cover these in detail as we get to them. Connect to the server, do while loop to send and receive data, gracefully close down everything, and then that's us, we're finished. So this is what we need to do to get this program to be a network client, and it's not there isn't that many lines of code. If there's 100 lines of code, there's too many lines basically. Okay, so to start WinSock, it's the exact same way as we did it for the bare bones server. So I need to create a WSA data structure, and I need a version number, which is a word 2, so I want version 2 of WinSock, and then I just want to start it. So I want to say int WinSock result equals WSA startup, and we pass in the version we want, which is ver, and a pointer to the data, so we need to pass in the address of the data. Now this data gets filled in if this returns true, so we can check to see if it not if it returns true, but if it returns null, 0. If it returns 0, then we have no error, and if it returns something else, then we have an error. So I want to say if ws result is not equal to 0, we want to write out the errors. Can't start WinSock, error number, and then we pass out ws result. Return. Okay. So that's us initializing WinSock. We pass in the version we want, it fills in this data structure. If it returns something that's non-zero, that means there's an error, and if there's an error, then we can't start WinSock and we should bail out early. So next thing we want to do is create a socket, and the socket is the identifier that our program will use to communicate with the network layer to send data out to the remote server, or the remote machine. Now, this is the same idea as we have on the server side, but this is us on the client side. So we have socket, and I can call it sock, easy enough. Call it whatever you want. We need to pass in the address family, so I'm using this form here, which is IP version 4, so that's why I've got AF INET. AF is address family, and then INET is the internet style address family. So when they first created this, the internet was version 4, which was just the version that we used for the longest time, so they didn't have a different version. If we wanted to use version 6, we would just add a 6 there, and then it uses version 6. The type of socket we want to create, which is sock stream, and then the protocol, which just leave it as blank. Don't leave it as blank. Put in 0, and it works out the protocol itself. So at this point, we want to check to see if the socket is valid. And if it's not valid, we want to bail out early and then tell the user that there was an error. So I'm going to do cr and create socket error. Now socket returns a valid socket number. So if it's a negative number, so invalid socket is -1. So if it's any other number, then it's valid. So in order to get the last error, like up here, the WSA startup returns the error code. To get the last error, we actually have to do WSA get last error. Okay. So that's us. We've created a socket. So we're getting through this quite a bit. So we initialize WinSock, create a socket, and the next thing we need to do is fill in the hint structure. Now the hint structure is going to tell WinSock what server and what port we want to connect to. So I'm going to say that it is a sock address IN, which is the hint. Why has it got in at the end? Because it's an because it's an IP version 4 version of this structure. So hint.address family is AF INET. Hint.syn port equals, and remember, because networking is big endian and I'm on a little endian machine, and even if I wasn't on a little endian machine, I need to turn something off for a sec. Otherwise it tones everything down and the screen looks weird. Even if I wasn't, I should use htons, because then I want to have my code be portable enough that I can take this and put it onto anything else. So I want to use htons, which stands for host to network short, and I want to use a port number. And now I want to add the address, and the way we use that is we use inet heton, which is inet, and then it's a pointer to a string to number. So I specify the address family again, and then I specify the address string, which is my IP address. And you notice that it's gone that squiggly there. It says no suitable conversion function string to PC str, which is a pointer to a C style string. But I can do dot C underscore str, and then I get a function. Make sure you put in the brackets after that, and that converts it to a string, to a C style string. Actually, it converts it to a const char star, but you know, for our purposes, it's converted to a C style string. And then we want to pass in the address of the buffer where the internet IP address goes. So this is going to convert it from the string version of 127.0.0.1 into the individual bytes and place that inside the array there. Alright, so that says we have our hint structure. Now what we want to do is we want to connect to the server, which is similar-ish to when we bound a socket to the IP address port number on the server. It's not quite the same, but it's similar to it. So I want to say int con result equals connect, and then we want to specify the socket, so we've got sock, and then we want to pass in the pointer to the address structure, so it's going to be sock address, and then it is hint, and then it's going to be the size of hint. And again, we want to check and see if this is valid, so we want to say if connection result not equal to socket error. Sorry, that equals socket error. Did I do that? Oh, yeah, I did that. Okay. If connection result equals socket error, then I want to output that something bad has happened, and we terminate the connection, or we terminate the program. Can't connect to server. Error number, and then we do WSA get last error. But this time we want to, because we actually have a connection, we want to tidy things up. So I want to close socket sock WSA cleanup, and then return. Because at that point I actually have a valid socket and I've been doing things with it, so I want to clean up there. And in fact, we should probably do that here. Now that I'm thinking about it, because we have actually done something here. We've initialized WinSock, so we should actually clean it up. So we should probably put that in there. Okay. Now, assuming that at this point of the code, line 49, we have everything we need to do. We've connected, we've created it, we've initialized WinSock, we've created the socket, we've bound that socket to a connection to a remote server. We now have this do while loop to write. So I need a few more variables here to hold some data. So the first thing is I want to create a buffer which is 4K in size. That should be good enough for our purposes. I also want to have a string for user input, and then I want to have a do while loop while user input dot size is greater than 0. And inside here I want to prompt the user for some text, send the text, wait for response, echo response to console. And I really do like writing these comments here, because then I'm kind of writing the program, I'm writing this sort of pseudocode for the program, but I'm also getting, you know, fairly good comments. And I don't need to think about the comments, because they actually become part of the program at that point. There's an argument for and against comments, but I kind of like them, that I can see that it's almost like there's a break in the code. Oh, this is the initialize WinSock part. Oh, this is the create socket part. This is the fill in the hint structure part, and so on. So it does help, I think. Okay, so I want to prompt the user for some text. So I'm just going to do a very basic prompt, which is that. And then I'm going to do get line cn user input. And I want to use get line because I want to be able to have spaces. And if I if I don't use getLine, I just use cin, then I'm not going to get the full line of text. I'm going to get, it's going to, if I do hello space world, it's going to send hello first, and then it's going to send world after that, and I want to send it as one piece of text. Okay, so send the text, so if, and then I'm just going to do this all in one line. Actually, no, let's not do it in one line. Let's do int send result equals send, and I want to send it out in the socket. And this is the buffer I want to use, which is user input dot c string, comma user input dot size +1, comma 0. And the reason why I want to do it as +1 is because if I send hello, that's HELLO, which is 5 letters. But in C, that's actually 6 letters because every string is terminated with a 0 character. So when I send the size of this, when I convert this to a C-style string, I'm actually sending 6 characters when I send hello, because I have HELLO and then I have that trailing 0 at the end, which is why it's the size +1. But really, I should check to make sure that size is like the user's typed in something. So I should do if user input dot size is greater than 0, do all of this. Make sure the user has typed in something. So I want to make sure the user's typed in something. What is that saying? Well, oh, because this is extra. Why is that extra? Don't know why I put in there extra. Okay, so send the text. So if send result is not equal to socket error, I'm going to wait for the response, and then I'm going to echo the response to the console. So my response is going to be bytes received equals receive, and then it's going to be the socket, the buffer, the length of the buffer, and then flags, which I'm just going to leave as 0. But I'd want to 0 that buffer out, so I'm going to use 0 memory buff, comma 496. And then if the client disconnects, bytes received is going to return 0. If an error happened, its bytes received is going to contain -1. So I only want to echo my response to the console if I received anything. So if bytes received is greater than 0, so in other words it's a positive integer, I'm going to do cout server, and then I'm going to do string, and then I'm going to specify the buffer, the 0th index, and then that's going to be bytes received and blank. So what am I doing here? I'm outputting this text to the screen, and then I'm outputting a brand new string that's made up of the contents of buffer from this index and this number of characters. And that number of characters is the number of bytes received. Okay, do I need to do anything else? Nope, I think we're good here. So we're at 80 lines just now. Right. So gracefully close down everything. So after that while statement, we need to close the socket. So we close the socket we just opened, and then we want to shut down WinSock properly, and that's it. So that is everything. So make sure you got everything typed in correctly, and then when you compile it, when you build it, to build it you press Control Shift B. It should succeed, should get one succeeded, all that kind of stuff. Now what we want to do is we want to go over to our server and make sure that we are on 54,000 and that's on any, and then we want to run the server. So this will run over here, and I'll clamp that over there. And I'm going to put the bare bones client here. And then when I run this, Avast will pop up, annoyingly. There you go. So now I run bare bones server, so it doesn't do anything there. And now I run my client, which has now been cleaned by Avast. So I have on this side here, I have my client, and this side here I have my server. So I can type in anything over here, hello world. And you see that hello world appears on my server side, and then over here I get my echo back here. So 1, 2, 3, this is a test. And so is this. So obviously we have a bit of a bug over here as far as output's concerned, but that's not a problem because we can actually just fix that while we're here. So if we go back to our bare bones server, down here we have our output here. So we want to do end line there, because it was missing this bit here. Alright, so now you can have that over here, and hello world, this is our test, so is this. Okay, and that's it. Hi guys, thank you very much for watching. If you liked the video, thumbs up. If you didn't like the video, thumbs down. And if you want to leave me a comment below, if you want to see more videos like this, then let me know. And because the algorithm has changed, I guess, please subscribe, please. It's really important to me. It's not really. If I can help, that's great, and if I'm not helping, then let me know. So anyway, thank you very much for your time, and I will catch you next time.